I'm Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. Today we are going to study about different types of AC bridges we have. In the last session we have discussed about one of the DC bridge which is used to measure the resistance. Similarly, we have many number of AC bridges. Those AC bridges are helpful to measure the inductance, capacitance and resistance also. Now, look into the one of the AC bridge. This is the general construction of an AC bridge. And similar to the DC bridge, AC bridge also consists of 4 arms. The 4 arms of the bridge are represented with impedances like the first arm is represented with an impedance Z1 and second arm represented with an impedance Z2, third arm having the impedance Z3 and fourth arm having the impedance Z4. So among these 4 arms, if any one arm is unknown arm, let us assume that Z4 is an unknown impedance. To measure the Z4 value, we need to find out the balanced bridge condition. Whenever the bridge is present in the balanced condition, we can measure this unknown parameter Z4. For any AC bridges, the 2 opposite arms of the bridge are connected to AC voltage, whereas the remaining 2 arms of the bridge is connected to detector. This is the general construction of an AC bridge. Similarly, the balanced bridge condition for an AC bridge is Z1 into Z4. Product of 2 opposite arms must be same. That is, first arm, the product of 2 opposite arms. 2 opposite arms means Z1 into Z4. And the product of another 2 opposite arms are Z2 and Z3. So, product of 2 opposite arms must be same. So, Z1 into Z4 equal to Z2 into Z3. From this, the unknown parameter Z4 can be measured as Z4 equal to Z2 Z3 by Z1. In this way, we can find out the unknown parameter in any AC bridge. Now, coming to one of the AC bridge, that is Maxwell's bridge. In this Maxwell's bridge, we have 4 arms. Similar to the remaining bridges, in this Maxwell bridge also we have 4 arms. The first arm consists of parallel combination of resistance and capacitance, and second arm consists of resistance R2, third arm consists of resistance R3, whereas fourth arm consists of series combination of resistance and inductance. With the help of this Maxwell's bridge, we can measure unknown inductance value. The unknown inductance is L4. So, by using this Maxwell's bridge, we can measure unknown inductance. Along with this, we can also measure the resistance R4. So, to find out these unknown inductance and resistance with the help of Maxwell's bridge, first we need to calculate Z1, Z2, Z3 and Z4. What is the need of calculating these 4 parameters means the balanced condition for any AC bridge is Z4 equal to Z2, Z3 by Z1. So, to measure the unknown parameter Z4, we need to find out Z1, Z2, Z3 and Z4. Then by substituting Z2, Z3 and Z1 in this equation, we can measure the unknown parameter Z4. So, first we need to calculate Z1, Z2, Z3 and Z4. Coming to Z1. Z1 means what? Parallel combination of resistance and capacitance. As we know that if 2 components are in parallel with each other, then the resultant is, if this first one is resistance R1 into 1 by j omega C1. The inductance of a capacitance is 1 by j omega C1 and R1 plus 1 by j omega C1. If you want to measure total impedance across the first arm we have resistance and capacitance, and these two are in parallel. If two components are parallel, then product of two components divided by sum of the two components. That is R1 into 1 by j omega C1 by R1 plus 1 by j omega C1. Similarly, Z2 can be represented as, we have only one resistance, that is R2, and Z3 can be represented as R3. Whereas Z4 is, here we have series combination of resistance and inductance. So, R4 plus L4 can be represented as j omega L4. Now we have four expressions like Z1, Z2, Z3 and Z4. Now substitute these four terms in balanced bridge condition. As we know that the balanced bridge is Z4 equal to Z2, Z3 by Z1. So Z2 means we know that R2, and Z1 is, Z3 is, Z2 is R2, Z3 is R3 and Z4 is R4 plus j omega L4. So Z4 R4 plus j omega L4 divided by Z1. We know that Z1 is R1 into, R1 into 1 by j omega C1 whole divided by R1 plus 1 by j omega C1. By simplifying this expression, we have j omega C1 in the numerator section, R1 by. Similarly, in the denominator section, by taking j omega C1 as the LCM, we have R1 into j omega C1 plus 1. So this is denominator and this is numerator. In both the terms, j omega C1 get cancelled, and finally we have an expression like Z1 equal to R1 by 1 plus j omega R1 C1. This is Z1. Now, in place of R1, now cross multiply this equation, then we have R4 plus j omega L4 into R1 by 1 plus j omega R1 C1 equal to R2 R3. So, by cross multiplying this equation, we have R4 plus j omega L4 into R1 by 1 plus j omega R1 C1 equal to R2 R3. Now, again simplify this expression as R4 plus j omega L4 into R1 equal to R2 R3 into, multiply this term here, 1 plus j omega R1 C1. Now, multiply each term with this R1, then R4 R1 plus j omega L4 R1 is equal to, multiply this R2 R3 with these two terms, then R2 R3 plus j omega R1 C1 R2 R3. Now we have both real and imaginary terms on both sides. So to measure L4, compare imaginary terms on both sides. Similarly, to measure R4, compare imaginary real terms on both sides. So by comparing real and imaginary terms on both sides, if you compare the real terms on both sides, we have R4 R1 equal to R2 R3. From this R4 equal to R2 R3 by R1. Similarly, by comparing imaginary terms on both sides, we have L4 into R1 equal to R1 C1 R2 R3. R4 R1 R1 get cancelled. Finally, L4 equal to R2 R3 into C1. So these are unknown inductance and unknown resistance. These unknown inductance and unknown resistances are measured with the help of balanced bridge condition. So this is a Maxwell's bridge. If you observe this Maxwell's bridge, this bridge is mainly used to measure unknown inductance. The unknown inductance is present across the fourth arm. So the unknown inductance is represented with L4 and unknown resistance is represented with R4. And we know the values of known resistances and capacitances across the first three arms. So the Maxwell bridge consists of four arms. Each arm consists of different electrical components like inductance, resistance and capacitance. Now for this Maxwell's bridge, to measure the unknown component that is present across the fourth arm, we need to consider a balanced bridge condition. Why? Because when the bridge is present in the balanced condition, then only we can measure unknown parameter. For this Maxwell's bridge, the balanced bridge condition is Z1 into Z4 equal to Z2, Z3. From this, Z4 can be represented as Z2, Z3 by Z1. So, by measuring Z1, Z2 and Z3, Z4 values, we can find out the unknown parameter by substituting all the four values in balanced bridge condition. So, we need to calculate Z1, Z2, Z3 and Z4. Now, to measure Z1, we know that the resistance and capacitance, these two are in parallel. So that the Z1 can be represented as R1 into 1 by j omega C1 by R1 plus 1 by j omega C1. Similarly, Z2, across the second arm we have only one resistance, so that it is represented with R2. And Z3, across the third arm we have another resistance that is represented with R3. And Z4. Across the fourth arm we have series combination of resistance and inductance, that is R4 plus j omega L4. Now we have four arms Z1, Z2, Z3 and Z4. Substitute all the four arms in balanced bridge condition. That is Z4 means R4 plus j omega L4 equal to Z2 is R2 and Z3 is R3 divided by the simplified expression for Z1, that is, we know that Z1 equal to R1 into 1 by j omega C1 by R1 plus 1 by j omega C1. By taking LCM in the denominator section and by cancelling j omega C1 on both the denominators, then we have R1 by 1 plus j omega C1 R1. Now substitute this Z1 value here and then cross multiply this equation. By cross multiplying this equation, we have R4 plus j omega L4 into R1 by 1 plus j omega R1 C1 equal to R2 R3. In this equation, again multiply this R1 plus j omega R1 C1 with R2 R3. Then the simplified expression is R4 R1 plus j omega L4 R1 equal to R2 R3 plus j omega R1 C1 R2 R3. Now, by comparing real terms on both sides and comparing imaginary terms on both sides, we can measure unknown inductance and unknown resistance. Now, if you compare the real terms on both sides, R4 R1 equal to R2 R3, then unknown resistance R4 equal to R2 R3 by R1. Similarly, by comparing imaginary terms on both sides, we have j omega L4 R1 equal to j omega R1 C1 R2 R3. By cancelling j omega and R1 on both sides, we have L4 equal to C1 R2 R3. This is unknown inductance. If the Q value is very high, we cannot measure the inductance value with the help of this Maxwell's bridge. In that case, we go for another bridge that is called as Hay bridge. If you observe the construction of Hay bridge, the construction of Hay bridge is almost same. with the Maxwell's bridge. Only one difference is in this Hay bridge, the resistance and capacitance. These two are in series. Whereas in Maxwell's bridge, the resistance and capacitance are in parallel. Except this, the remaining all are same in Maxwell's and Hay bridge. So, this Hay bridge also used to measure unknown parameter like L4. This Hay bridge is also used to measure inductance value with a very high Q value. In this Hay bridge also, to measure this unknown parameter, we have to find out the balanced bridge condition. Why? Because if the bridge is in the balanced condition, then only we can measure unknown parameter by substituting all the four impedance values in balanced bridge condition. So we have the balanced bridge condition is Z4 equal to Z2 Z3 by Z1. Now we know that Z1 equal to, so the resistance and capacitance, these two are in series. Then we can add these two, that is R1 plus 1 by j omega C1. Similarly, Z2 equal to R2 and Z3 equal to R3 and Z4 equal to R4 plus j omega L4. This Z1 equal to R1 plus 1 by j omega C1. The expression can be simplified by taking j omega C1 as the LCM. Then we have j omega R1 C1 plus 1. Now we have Z1, Z2, Z3 and Z4 values. Now substitute in balanced bridge condition, that is Z4 equal to Z2, Z3 by Z1. We know that Z4 is what? R4 plus j omega L4 equal to Z2 is R2 and Z3 is R3 whole divided by Z1 means 1 plus j omega R1 C1 by j omega C1. Again, to measure this R4 and L4 values, cross multiply this equation. Then we have R4 plus j omega L4 into 1 plus j omega R1 C1 by j omega C1 equal to R2 R3. Now we can multiply this j omega C1 here. So R4 plus j omega L4 equal to j omega C1 into R2 R3 by 1 plus j omega R1 C1. This is the expression for R4 plus j omega L4. But in this equation, the denominator consists of an imaginary term. If an imaginary term is present in the denominator, then to get the complete solution, multiply the entire equation with 1 minus j omega R1 C1. Then the denominator, this imaginary part can be removed. Okay. R4 plus j omega L4 equal to j omega C1 R2 R3 by 1 plus j omega R1 C1. For this equation, the denominator consists of an imaginary term. To remove the imaginary term in the denominator section, we have to multiply the entire equation with 1 minus j omega R1 C1 by 1 minus j omega R1 C1. Now, multiply these two terms, then we have R4 plus j omega L4 equal to, multiply each term with this term, then we have j omega C1 R2 R3 minus j into j means j square, which is equal to minus 1. Minus into minus plus omega square R1 C1 square R2 R3 by 1 a plus b into a minus b, a square minus b square, 1 minus j square mix plus omega square R1 C1. Now Compare real and imaginary terms on both sides. If you compare real terms on both sides, then we get the expression for R4. The real terms are R4 and this one. Then R4 equal to omega square R1 C1 square R2 R3 by 1 plus omega square R1 C1. Similarly, we can represent L4 as C1 into R2 R3. This is the way how to measure unknown inductance with the help of Hay bridge. Whether it is an Hay bridge or Maxwell's bridge, the main condition is we have to measure whether the bridge is present in the balanced condition or not. If the bridge is in the balanced condition, with the help of balanced bridge, we can measure the unknown parameter. Here the unknown parameters are inductance and resistance, which are present across the fourth term. Now we have calculated L4 and R4 values. This is about one of the AC bridge which is used to measure unknown inductance. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.